Today what we are going to do, we are going to start with a new chapter, and that chapter is about visualization of data. Whatever is there in your syllabus in Python Panda, we covered in the earlier sessions, right? One more important thing is that current session, the second chapter of Python Panda, that means Panda part 2, has been deducted. It is not there in your syllabus right now. So let us start. What is data visualization? What is the meaning of the term data visualization? First, we will understand what is data visualization. Data visualization is representing your facts or figures in a way of representing it as a chart or a graph, right? It is said that a picture speaks a lot more than words, right? So what you need to do is that you have to represent your data, which is in facts and figure forms or a tabular form, into a graph, so that it reveals something more prominently. Using it, the user can understand what is going on inside the data, what the data actually is revealing. That particular aspect user can identify very easily. So data visualization chapter is all about using data and making charts and graphs out of it. So here in this session, we will consider about how to make data visible, means how to visualize our data using Python Panda and MATPLOTLIB, which is a special module, package actually, rather than module. So under that package, we have another module named as PyPlot. So we will understand what is the use of PyPlot and Python Panda and how they can be used to plot a graph or a chart, right? So in this chapter, we are going to see a lot of graphs and charts like bar graph, how we can plot a bar graph for a particular data set, or how can we plot a line chart for a data set, how we can decorate our charts. There is a decoration associated with chart. That means you have to label the x-axis, y-axis, you have to label the legends, etc. All those things we will see here. How to represent our data in a more meaningful manner, so that it reveals much about it. Okay, so that part we are going to deal in this particular chapter. So let us start. So data visualization using sorry, data visualization using Matplotlib. So what is data visualization actually? What is data visualization? Data visualization refers to what it refers to. It means graphical or pictorial representation of our data using graphs, chart, etc. Right? As we have seen that, I told you that what is our data visualization? It is nothing but it is putting your data or the different data sets in the form of graphs, charts, and more or like that. Okay, so it's a pictorial representation basically. So now, what is the purpose? What is the need? What is the need for having this data visualization? The need for having this data visualization to represent your data in much meaningful manner, right? So the purpose is to visualize the variations happening in the data. The variations, whether it be a positive variation or a negative variation, to visualize variations happening in the data. Happening in the data over a period of time. So that is what is the purpose of data visualization. Okay, so you have to visualize data and you have to understand what variation is happening inside the data. It also represents the relationship. Between two different variables for which we plot them, for which we plot the graphs. You know that in a graph, let's understand the basics of a graph. I know that you know that, but still, let us revise it. We know that in a graph, this is what is called as x-axis, and this is what is called as y-axis. And any point lying on this graph has a abscissa and ordinate. That means it has a x coordinate, it has a y coordinate. The x coordinate is the distance of it from the x-axis, and the y coordinate is the distance of it from the y-axis. Right, at this junction point we get a point particular. So like that we can plot as many as points possible in this area of graph, right? So this is what is called plotting. So actually what we are doing, we are having a relationship, we are building a relationship between the x and the y variables. X variables are known as independent variable, these are called as independent variable, as you know that, and these are called y variables are called as dependent variables. So what we are doing here, we are putting the relationship between independent and dependent variables x and y, right? So this is what is the need of the graph, that it also shows the relationship between two different variables and the variations of data when plotted between these two variables, right? So that is the purpose of a graph, and it gives a clear-cut idea. It gives a clear-cut idea about what is happening in the data. Also, there is a need. There is a very important point here to understand, is that plotting a graph for data also gives us opportunity to understand what future variations of data can be. That means you can understand in future how the data will behave in future by just seeing the graph, by interpolating graph. These are called as interpolating. So graph interpolation is done for that. So graph interpolation reveals the future data variations. So what data variation will happen in future, you can reveal by understanding the ups and downs in the graph, right? How the graph is proceeding and what will be the condition of graph, this variation after a few days or a few hours or after a few years, that you can predict. So prediction is another thing, important thing that we can do by observing a graph. So if you are going to observe a graph, we are also going to predict something, right? As you can see that, I will show you one thing. This is a very important example. Nowadays, we are suffering from disease corona, right? The corona is everywhere. Now, this disease is not going to end very soon. And every day we are getting statistics about the infections, right? So let us find out how these infections are represented in a graphical manner. You can see that there are a lot of websites which shows these particular graphics, right? So let us go for to see one of such graphical website. Uh, as we know that there is a website called covid19india.org. So we can just move on to that particular website and then find out the graphical representation in it. The first page itself reveals the statistics. You can see here. Just see here the graphs, the different forms of graphs are being used. As you can see that there is a warm graph. There's a warm graph which shows you the confirmed the number of confirmed cases, active cases, recovered cases, disease cases. So this is actually a graphical representation showing the increase in the disease, the increase in the patients, the increase in the recovery, or the decrease in the recoveries, or the deceased, or the infected persons, right? It gives you the statistics in a graphical manner, right? Now you can see that there is another graph over here. You can see these are the called bubble graphs. These bubble graphs are also there, which shows you the area of infection, how much prevailing the infection is there in a particular area. So it also shows the prevalence of that disease in a particular area, right? So and now you can see here one bar graph is being used. As you can see here, bar graphs are used to represent different aspects of a particular state. This is being shown for Karnataka. You can just change it out and you can go to West Bengal to find out what variations of disease is being shown in the West Bengal, right? And now this red shows you the number of confirmed cases. The blue shows you the number of active cases and the recovery cases and the deceased cases. And month wise, it is going month wise and day wise, right? So the graph which is shown here just right now in your front and before you, that is day wise, between a week from 8 August to 15 August, what is happening from 15 to 20 August, what was happening. Now you can see the curves of the graph. You can see the curves of the graph. It is now a bit sinusoidal graph, right? है ना, ये sinusoidal graph से ups and downs में चल रहा है, isn't it? So you can just infer what will be the near future of the graph, है ना? So you can infer that also. So that predictions can be done by the graph, right? Now you can see this is another type of line graph. This is called as line chart, which is being made out of the thing. Now this is what is frequency distribution graph. The last one. The last one is the frequency distribution graph. This is the frequency distribution graph. In a month of April and July, what is happening? And then what will happen in the future particular month, in the future month, right? So that is what a graph can do. It can represent the situation very well. It can reveal the situation in such a manner that even a layman who doesn't know how to see the data, how to infer the data, can visualize it and can understand what is going to happen or what is happening now, right? So this is very, very important point to understand, that a graph reveals much information than the textual data. What has been written in the table, nobody is going to see. What will be the effect of that data is being shown, is being revealed by the graph, right? So that is what the point is, that we need this graphical representation every now and then. And now in the business world and commercial world, these representations are very important because it shows the future of the particular company or future growth of the particular business firm or entity, right? So the graphical representations are very, very much needed aspect when we are plotting, or when we are saving data, and when we are analyzing data, we are doing some analysis, statistical analysis. This graphical representations comes into the scenario. Very well, it fits into the scenario because we must represent our graph after collecting the data, so that in a very quick manner, in a spontaneous manner, we can reveal what is we can understand what is being shown, or what is happening with the data, right? So this is what the effect of that graphical plotting is. Now let us come to the point that how we can do that in Python, right? So our topic now is how we can best do this graphical plotting in Python. So let us find out the examples of graph. There are many examples of graph, as I showed. Examples of graph, examples of plots or graphs. Useful examples. The prevalence of corona disease in different parts of India is represented, can be represented very well using a graph. Now I would like to see I would like to sorry, I would like to present important graph too, which shows the prediction of the disease after a few months or after a few days. What will happen? Let us see that. The future prediction. As I've told you, the graphs also shows the future prediction. Let us find out how well it shows the future prediction. So there is everywhere there is a talk about the third wave of the disease, right? So let us find out when the third wave is going to come and what are the graphical predictions. So expected third wave in India, and for that there is a graph. I hope that is there. So they have interpolated something. Yeah, this one you can see here. This graph you can see. This is an interpolation graph by IIT Kanpur. They have made one interpolation graph, and they have taken various accounts of things like when the things will be going up and when the things will be coming down. As per their interpolation, you can see that their line of interpolation goes up in the month of after July. It goes up, and the peak we can be somewhere in between September to November. The peak is being shown here in the month of October, I think. Yeah, it is shown in the month of October, right? And then again, or if the now they are showing three types of graph here, right? They are showing three types of graph. That is one without enough vaccination, with vaccination, and something with precaution, and like that. So you can see that if we are not without any precaution, we are going on. No, vaccination is not so much means they are not, we are not going for the bulk vaccination, then the graph will be something like this. The violet graph, as you can see here, the violet graph is showing thus that the peak of the corona will come very soon, right? And then there is something with vaccination, the peak may not be so high. The number of people infected will not be so high. And if vaccination as well as masking is being done in a proper manner, then we can avoid the peak in the month of October, and it can go up to November. But the peak will come sooner or later. That is sure. That is sure that peak will come sooner or later. The only question is that the number of people going to be infected. As you can see that this particular altitude in the graph reveals that what will be the range of number of infections. है ना? ये जो altitude है, this altitude is showing you what will be the actual number of infections, right? As you can see that that number of infection can be greatly reduced if we are going to having a good precaution by using mask regularly and vaccinate. If the people are more and more people are vaccinated, then this can be avoided. The graph can be avoided. So this is interpolation. This is what is called as expected interpolation by the people. So graphs are also important for this particular purpose also. Okay, so let us find out. Let us find out what are the other things that we can do with the graphs. So, this is an example. Then other examples can be a graph can be like that. Graphical representation is not only in the form of plots. It can be something which is nowadays which is called as infographics. Nowadays we have infographics. This particular things are very much popular nowadays. Infographics. Infographics means information along with graphs. Information, some important information along with graphs. This particular thing is very much needed. Okay, nowadays. So infographics are also very important. So this is also example of graph only, the visualization. Now let us move on to the next thing, that is plotting of graph in Python Panda, or plotting of graph in Python. So plotting of graphs and charts in Python. Now, there are two methods of plotting a graph or a chart in Python. So in Python, there are two ways, or following ways of plotting the graphs or charts. What are the two ways? Number one is plotting using the package MATPLOTLIB with a module within it called what? The module is module within it called as pyplot. Okay, so this is one of the thing, graphical tool or graphical modules. And the second method is plotting using Python Panda functions, Panda module. So Python Pandas module can be also used for plotting the graph. So for plotting the graph, you can use Python Panda module also. You can use MATPLOTLIB. So these are the two different methods of plotting a graph. Now let us first understand how to plot the graph using MATPLOTLIB. So installing, so first you have to install MATPLOTLIB. Installing MATPLOTLIB package, so that you can plot the graph using it. To plot the graph using MATPLOTLIB, no, you have to first install the MATPLOTLIB package. So how to install the MATPLOTLIB package? This is quite easy. Like you were installing every other thing in Python, you can install the MATPLOTLIB package also by writing the command. The command for that is command that should be entered in the command prompt. And executed. The command is pip install matplotlib. What this will do? This will just install matplotlib as a package. And along with that, your pyplot will be also installed because it is inside the package itself, right? So pip install matplotlib is enough for writing that. Okay. Now, how to use? After installation, we must be using it, right? So using pyplot in our program, using pyplot module in our program. Matplotlib has a very important module within it known to be PyPlot. That is called as PyPlot. Known to be PyPlot. We can use this package, this module by importing PyPlot in our program. So by importing PyPlot in our program, you can just import this module. So how you can use this module? How to import? Now, since this is part of a package, PyPlot is a part of a package, you must import it along with the Matplotlib package. So what you have to write? You have to write the fully qualified naming, FQN. You have to import PyPlot along with Matplotlib. So what you have to write? The syntax for that is, syntax for importing the PyPlot is, you should write like this: import matplotlib.pyplot as, and then alias name can be given, like we were giving for pandas as PD. So PyPlot as PLT you can give. More commonly it is given as PLT. So import matplotlib.pyplot as PLT. So this will import, this will add this matplotlib module into your program, and now you can use the features under it, the features which are available in PyPlot to plot a particular type of graph, right? So this is the first thing that you have to do. Now let us understand the important parts of a graph. Let us understand the important parts of a graph. Let's find out what are the different important parts of a graph. Means when we are going to plot a graph, we must understand what are the different parts of a particular graph. So let us find out what are the different areas of a or different parts, sections of a graph. So let us find out. Just let me upload a picture for you. So this is the picture for you to understand. As you can see that these are the different parts of a graph. These are the different parts of a graph. I hope it is visible to you. So these are the different parts of a graph, right? As you can see, these are the components of a graph. Okay. Now let us understand, let us know the different parts by understanding this particular things. The first thing is y-axis and x-axis. As I've told you, you can see that this is y-axis and this is x-axis. This is x-axis and this is y-axis. Here you can see that we have plotted years in x-axis, which is independent. The time is the most independent thing we have, right? Variable. Time is an independent variable, or year is an independent variable, right? So this is what we have. This is x-axis, and x-axis is an independent. We have independent variables in x-axis. So year wise we are having 2013. From 2013 to 2017 we have plotted the graph, and we are plotting, we are just plotting the number of years passed and the amount of business the following three companies, Microsoft, Apple and Alphabet, has done. Alphabet is for Google. So Microsoft, Apple and Alphabet, these three companies, what business they have done, we have plotting their business in the terms of graphs. Now you can see that from the above graph, you can see that we have also plotted on the y-axis, we have plotted their numbers in millions or billions maybe. So 0 to 50, 50 to 100, and like that. Now these are called as y-ticks. These values, no, these intervals are called y-ticks. Y-ticks are y intervals. These are y intervals. Y intervals are called as y-ticks, and x intervals are called as x-ticks. These are x-ticks. These are x-ticks or x intervals. Okay. So these are the two intervals, y intervals and x intervals. These are called as x-ticks and y-ticks. Please understand this one. These particular terms, x-ticks and y-ticks. These are useful terms, x-ticks and y-ticks. Now you have, every chart should have a chart title, which is written at the top of the chart. So you must have a chart title over here. So this is also important component, chart title, right? And then the chart title is comparison. We are comparing the three companies. So the chart title is comparison. That at the top of the plot, you will have a chart title. Now, every axis should have a label that is called as axis title. Now here you can see that axis title is year And here you can see that the axis title is numbers. So these are called as axis titles. These are axis titles, as you can see that it is given in the figure itself. Now, how can we understand that which line is for which company? The red line is for Apple, or the blue line is for Apple, or the yellow line is for Apple. Which line is for which company? For that, to understand that, we draw what is known as legends. We draw legends. So these are the legends: Microsoft, Apple, Alphabet. And you can see that from legend it is quite it is revealing that Microsoft is having what the red line is for Microsoft, the yellow line is for Alphabet, that is Google, and for Apple it is black line. Black line is for Apple. And then you have plotted section, the plotting section where the actual plots are being made. So these are called plotted data. These lines reveals what are known as plotted data. The lines reveal the plotted data, right? So these are the important areas of a graph. So what are the important areas of a graph? Let us jot it down. The first important part of the graph is the chart title, right? Or the chart graph title, right? This is an important area to show what the graph is about. What the graph is about. Then the next important part is coming as what? The X label and the Y label, right? The axis label, right? Axis titles. So axis titles are to show X axis and Y axis, labels or variable names for which the graph is being done, variable names. Okay. And then we have what? We have another section, and that is for the third one is X ticks and Y ticks. X ticks and Y ticks. These are to show the respective data intervals on X axis and Y axis respectively. As you can see that here in this case, in our graph, in the given example graph, the X ticks are the year numbers 2013, 14, 15, 1 year. It's an interval of 1 year. Within 1 year, what is the growth from, right, starting from 2013 to 2017, right? And the Y ticks are numbers which are having an interval of 50-50, right? So we have an interval of 50, 0 to 50, 50 to 100, 100 to 150, like that. The interval is going on the Y axis. So they are called as Y ticks. They are called Y ticks. Now we have X axis and Y axis, that you know very well, because in mathematics also we have graphs, and we know that what is X axis and Y axis. That's not important thing. Now here the next important thing is legend, and these legends are nothing but these source to show. It is used to show the markation for different entities for which the graph is plotted, for whom the graph is plotted, isn't it? So that is what is called as legend. So these are the few important parts of a graph, and above that we have what is known as, sometimes it happens that our graph will have data points. Our graph will have data points like this. It is here, then this will be here, this will be here, this will be here, this will be here. So these are called data points. Our graph may have data points. It's not there in this graph, in this particular example graph. It is not there, but you can have data points in your graph. You can have different data points in your graph. Right? You can have different data points in your graph which can be plotted. Now these are called as, these data points are what are they known as? They are called markers. These data points means the symbols you are using to mark the data points are known as markers. They are called markers. Remember that these data points, the symbol of this data point, it can be a round symbol, it can be a square symbol, it can be a rhombus symbol, it can be an arrow symbol, any symbol you can use. Those are called as markers. So you can specify markers on your line chart or graph also. The path of the graph can be marked by the markers, right? So they are called markers. And then you can always set the width of this line. You can change you can customize the width of these lines, of the graph lines, by passing appropriate parameter. We will see that in a while. And then sometime it happens that the line chart in itself is not a solid line. It can be a dotted line like this. So you can also customize these line charts as a dotted line. Instead of solid line, you can also make it as So let us find out. So our data values are, our data set is as follows. The data set that we are going to work upon is as follows. We have to take dates as these values. We have to take the dates values as the date values will be, say, from starting from the 1st of September 2021. We will go to 2000. We will plot for 2nd of September. We will plot for 3rd of September. We will plot for 4th of September. And we will plot for 5th of September. Today, up till today, these 5 days we will plot. So let us plot and the temperatures will be, you know that this representation is a mathematical representation. For graph, this is given always, right? So the x values and the y values, right? So x-axis values are dates, and the y values are, or the dependent values are, the temperature. The temperatures are on 1st of September. Let's say the temperature was around 29 degrees centigrade. And then on the 2nd of September, it was around, say, for example, 27 or something like that. And then again it rose and it went to 30 degrees centigrade, and then again 28 degrees centigrade. And then it was today it is quite cool, and then that is around 27 degrees centigrade. So now let us plot this graph and see how it works. So for plotting this graph, what we have to do? First, we have to, so plotting graph between dates and temperatures. So it's quite easy to plot graphs between date and temperature. What you have to do? First, you have to import, right? So you have to write import matplotlib .pyplot as plt. And after that, what you have to do? You have to simply declare the data set. So first you have to declare the data set. We'll write the data set over here. So we will have what? We will have those two things. First will be the dates, and that will be a list of dates, isn't it? Because we have multiple dates, and for keeping multiple things in Python, we use lists. So better thing is to have a list. So let us plot the dates as this one. We'll see that dates will be something like this. The first date is 1/9/2021. Then the second one is 2nd/9/2021. The third one will be 3rd/9/2021. 4th/9/2021, and so on. And the list will be closed. Then after that, after dates, we have temperature, and we will have these five different temperatures for them. We decided for which values? We decided for values like 29, 27, 30, 28, 27, 29, 27, 30, 29, 27, 30. So 29, 27, 30, 28, 27. So these are the values we decided for, right? Now this is dates and these are temperatures. Don't write degree centigrade over here, because those will be numeric values only. No. So now let us plot these graphs using this particular thing. So for plotting them, what you need to do, you have to use which function? Plot function. We will use plot function to plot this particular graph. Okay, so plot function will be used to plot these graphs. So how to write? So plotting graph using plot function. Plotting the graph using plot function. How to use the plot function? It's quite simple. Simply you have to write PLT. Now what is PLT? PLT has been taken as an alias name for matplotlib.pyplot. So instead of PLT, you can directly write here matplotlib.pyplot. isn't it? So plt dot plot, the function name is plot, isn't it? The name of the function is plot, and inside this function you have to pass two parameters. The first parameter will be your x-axis, and the second parameter will be your y-axis. The syntax for plot function is that first you have to pass x-axis, and the second thing that you have to pass is the values of y-axis, corresponding y-axis. So what we will do, we will write here dates, comma, and here I will write temperature, and I will close it out. And then we can write the last line to show the graph. This is up to plotting, but after plotting you must show the graph to the user. To showing for showing the graph, what we have to do, to show the graph we have to write so showing the graph back to the user. So to show the graph back to the user, what you need to do is that you will simply write here plt dot show. plt is the object for plot, the plot that you have made. So you have to show that plot now. So plt dot show. So this will show your plot, and the graph will be revealed and shown, right? So let us just do this practically in using our Python idle. So I hope the code is visible to you. So let us do that using a Python idle. What we will do, we will just simply start a new program and write the program over here. So plotting of graph between dates and temperatures using pyplot. So what you have to do, you have to simply import matplotlib. Since I have installed matplotlib in my machine, I did not do that again. But if you have not matplotlib installed in your machine, you must install it by using pip command, right? That I have told you earlier. Pip install matplotlib. That command should be run in the command prompt. So import matplotlib.pyplot as plt, and then you have to declare the dates. The dates you should declare. The dates you should declare. Isn't it? The dates you should declare. You should declare the dates. These dates should be declared. And you should declare what? The values of temperatures. The temperatures will be equal to what we have decided, that value should be written here. We have decided with 29, 27, 30, 28, 29, 27, 30, 29, 27, 30, 28, and then again 27, I think. Yeah, 28, and then again 27. So 27, this is what the temperature is. Now what we have to do, we have to plot these two things using the graph. So what you have to do, pyplot dot, so you have to plot the graph. So plt dot plot, and here you will pass the dates and temperature. And then you have to show the plt dot show. Plt dot show will show the temperature. Now let us run the graph. Let us see how this particular thing shows you up. Run module. So the name of this will be date versus temperature. So date versus temperature. Replace it. Now let us run. Module not found. Matplotlib. It's not matplotlib. Actually, it is matplotlib. Matplotlib.pyplot. Now let's run. Now you can see the graph before you. So the graph points are being shown here. It is shown that the graph started with 29 degrees centigrade on 1st of. You can just see this plotting. You can verify these plottings very well. These plottings are quite revealing themselves. So this is 29 at this x-axis, and this is going down to 1st of September. Then again it is 27. This is the lowest temperature we have, and this is down to this one. Okay. Then again it is 30 degrees centigrade on this particular date, and is going down here to 3rd of the September, right? And then again we have 28 degrees centigrade, and is going down to there. So these are the data points. These are data points actually. And then again 27. Again we have 27. So again this will go here, and we will get the data points. So what are the data points? What are the data points we are getting? We are getting the 4 data points here. This one is one data point. This is another data point. This is the 3rd data point, and this one is 4th data point, and this is the 5th data point. So these are the different data points we have. These are the different data points we have, right? Right, starting from the first of the things, it is going down like that. So these are the data points we have. So these are the data points which we are being plotting here, right? Now you can save this graph. You can see that this is a separate window that has been given, and this window is being shown because of the thing that you have written, the last line. Because of that last line, this particular window is being shown, and that was plt.show. If you would not have written that particular line, what would happen? The plot will be created, the object will be created, but it will not shown. So to show the graph, you must write the last line, plt.show. Right now you can see there, you have controls over here. You can see that there are controls over here. You can just what, you can just paginate your graph. You can snap your graph like this. Okay, you can just snap your data values like this. Means if this particular graph would having more data points, so you can just go through every data point by sliding it. So you can just span paginate. You can just paginate and snap in your graph by this, right? Roll. You can roll back on the page of the graph, right? And then there is a handle called magnification. You can do the magnification also. A particular area will be magnified. So like that, magnification can be done. And then if you want to, you will press home. The graph will come to its original state as it was there in the first place, right? And then you have these controls. These are the controls. Uh, these are the controls for left, right, and top and bottom and width space and height space. You can just set them. You can reset these things. You can just reset these things from the control. Your graphs, yeah, these controls are used to customize your graphs. You can just reset this left width, height, and then suppose you want more height in the graph, right? So what you can do, you can go for top and you can decrease it. So more height will be given in the top, at the top place. So you can just adjust all these things over here, and then you can reset the graph. You can reset the graph so that it comes to the original shape and size. So these are the controls that are there, and the most important control is that you can save this graph. You can save the figure of this graph by using this save control. You can click on that and it will ask you where to save, and you can just save it as a PNG file. So you can save that file as a PNG file. Now there is a function also called savefig. There is a function called savefig which can be called by code to save the graph. The same thing, the same thing which you are doing here by clicking the control, the save button. You can do that using your code by using what? A function called savefig. There is a function called savefig. We will do that. We will do that in a while. So this is all about plotting the graph and executing the program, right? Now let us move on to the next thing. Let us move on to the next thing. Let us find out what are the different types of functions with the plot function, plotting. Now, what are the different plots you can make? What are the different types of graphs we can make in the pie plot? So let us find out what are the different types of graphs we can plot in a pie plot. 93. So this will be of 7%. So this is all making what? This is all making what? This is making 100, right? So that is a pie chart. That's a pie chart. Okay. And then we have what? We have other thing like different other chart, scatter plot. A scatter plot looks like this. You have, so this is pie chart, and then you have a scatter plot like this. The values will be scattered, and the more values are nearer to each other, that means the density will be more there. So this data shows the density of particular thing over a time period, how it goes on. So this is also a scatter plot. This is a scatter plot. Okay. So every graph has its own function, has its own situation where this particular graph can be used. We will see each one of them in the coming time, right? So today what we have learned, let us wind up. What today we have learned? We have learned about what is data visualization. We have learned about what is data visualization. Then what else we have done? What else we have done? After data visualization, what we have done? After data visualization, we have seen what are the different modules or packages which we can use in Python Panda to produce this type of visualization. We have understood what is the benefit of visualization. We have seen how visualization makes it more clear to understand our data, what the variations are going on inside the data. Then we have seen different types of a mechanism by which we can write code in Python to create a line graph, right? We have seen a simple example where we have plotted a line graph between a temperature versus dates, right? And then we have seen afterwards that what are the different other types of plots we can plot using PyPlot. So these are the things that we have discussed. And today's homework will be for you, will be to do this one. Please try it and show it back to me. The homework is something like this. It goes like you have to create a particular graph. You have to create a graph which will try to show the difference between two people. That means, say for example, if I want to plot a graph, plot a line graph, to show variation among different quarters and sales as per following data. Now the data you are having, what we have quarters, we have quarter 1, quarter 2, quarter 3, we have quarter 4, and then we have what? We have the sales data. We have the sales data 3,000, 1,000, 1,700, and then 3,500. So these are the sales data we have. So you have to plot a line chart between these two quantities and see what it gives us. Okay. So for today, this much only, and I'm leaving you with the homework so that you can do it and you can show it back to me. Okay. Thank you for this session, and we will meet. Have a wonderful day, and we will meet again next week.